all of a sudden, we realize that we may have to rethink some aspects of our understanding of interstellar space. Something intriguing has emerged. We may need to refine our models of the universe beyond our solar system. A modern AI system processing decades of Voyager data has detected something noteworthy in data from Voyager 1. This finding is significant enough to spark new questions about our understanding of interstellar space. This isn't just another glitch or sensor malfunction from aging equipment. What this advanced AI detected offers new insights into the physics of deep space and our exploration of the universe. But what exactly did it find, and what does it mean for the future of space exploration? Why is this finding generating excitement among scientists now? The implications reach far beyond astronomy, touching on questions that have inspired humanity since we first gazed at the stars and wondered about our place in the cosmos. The finding came when NASA scientists decided to reprocess Voyager 1's historical data using a new AI system designed to detect patterns invisible to conventional analysis methods. This AI, developed as part of a project to search for subtle anomalies in deep space data, employs advanced computing techniques that allow it to perceive correlations and patterns that might be overlooked by traditional systems. The results were intriguing. In a series of data sets, collected as Voyager 1 crossed the heliosphere boundary, the edge of our sun's influence, the AI identified an unusual pattern in particle or magnetic field data that warranted further study. These data, captured by Voyager's aging instruments between 2012 and 2015, showed nothing unusual to human analysts when they were first received. But the AI, looking deeper into the data layers, found something noteworthy. The pattern appears as a subtle variation in data, possibly related to plasma density or magnetic fields, visible only when the AI enhanced and compared multiple data sets using advanced pattern recognition algorithms. The pattern exhibits a level of complexity that suggests it could be a natural phenomenon worth investigating further. What makes this interesting is that this pattern seems to correlate with Voyager's position relative to the heliosphere boundary. In other words, it's as if Voyager 1 encountered a new feature of interstellar space as it crossed this threshold. Initial analysis ruled out sensor artifacts, data corruption, or transmission errors. The pattern consistently appears in multiple data sets from different instruments, suggesting it may reflect a real phenomenon rather than a technical glitch. Is this just a subtle artifact of aging equipment billions of miles from home, or could it be something that enhances our understanding of interstellar space? The scientists involved began to explore new questions about the physics of deep space. If this kind of fascinating science excites you, make sure to subscribe. We dive into discoveries like this every week. Hit that notification bell too, because what you're about to hear gets even more intriguing than you might imagine. The story of what Voyager has potentially revealed could deepen our understanding of the universe. To understand the full significance of this finding, we need to appreciate just what Voyager 1 is and why it matters. Launched on September 5th, 1977, Voyager 1 is humanity's most distant explorer, a one-ton spacecraft now traveling at about 38,000 miles per hour through interstellar space. When it left Earth, Jimmy Carter was president. The first Star Wars movie had just been released, and the internet didn't exist. Its primary mission was ambitious, but relatively straightforward: to study Jupiter and Saturn, taking advantage of a rare planetary alignment that occurs only once every 176 years. After giving us our first detailed views of Jupiter and Saturn in the late 1970s and early 80s, Voyager 1 continued outward, eventually crossing the heliopause in 2012, becoming the first human-made object to enter interstellar space. This humble spacecraft carries instruments designed in the 1970s that are somehow still functioning, powered by radioisotope thermoelectric generators that convert heat from the decay of plutonium into electricity. It's a technological miracle that we're still receiving any data at all from something so distant and so old. The signal Voyager sends back is incredibly faint, about 20 billion times weaker than the power needed for a digital wristwatch. What's even more remarkable is that Voyager 1 carries the famous golden record, a time capsule of Earth sounds, music, greetings, and images intended for any intelligent extraterrestrial life that might find it someday. This 12-inch gold-plated copper disc contains everything from Bach to Chuck Berry, whale songs to human laughter, and greetings in 55 languages. It represents humanity's first deliberate message to the cosmos, a bottled note cast into the vast cosmic ocean. The spacecraft has enough power to maintain communications until approximately 2025, after which it will continue its silent journey among the stars, potentially outlasting human civilization itself. In about 40,000 years, it will pass within 1.6 light-years of the star Gliese 445. It's against this backdrop, a 46-year-old spacecraft carrying a message to the stars, that our AI made its intriguing discovery. A technological relic from the disco era may have provided new data that our modern observatories can further investigate. So what exactly is this pattern that appears in the enhanced data? The leading theory from NASA scientists is grounded in current research. The pattern detected by the AI may reflect variations in the interstellar medium, such as changes in plasma density or magnetic fields, as predicted by models of the heliopause transition. Essentially, as Voyager 1 moved beyond the Sun's influence, it encountered a region where particle and field interactions create complex patterns. These variations were first studied in data from Voyager's plasma and magnetic field instruments. While these patterns are complex, they align with theoretical expectations of the interstellar medium structure. The problem: such variations were expected to be subtle and difficult to detect with Voyager's aging instruments. To put this in perspective, Voyager's sensors are operating at the limits of their design, yet they've provided data that modern AI can analyze for new insights. Yet here it is, apparent in Voyager 1's data when enhanced by AI. One NASA scientist, Dr. Elena Reyes, proposed that what we're seeing might be a detailed snapshot of the interstellar medium, revealing structures that were previously too faint to detect. The interstellar medium beyond our solar system may exhibit properties we're only beginning to understand. The boundary between our solar system and interstellar space is more than just a transition in particle density and magnetic fields. It is a region where we can study the interface between our solar system and the broader galaxy. Dr. Reyes theorizes that the interstellar medium, combined with the unique environment outside our solar system's protective bubble, could reveal new details about cosmic plasma dynamics. It's like seeing the interstellar medium in unprecedented detail, she explained in a recent discussion, something we're only now able to study with advanced tools. Could this finding enhance our knowledge of interstellar space? Absolutely. If confirmed, it would provide valuable data about the heliopause, a key area of study in space science. These findings build on decades of research into the structure of our galaxy. But there's another possibility. What if the pattern reflects something unexpected in the interstellar medium? Here's where things get truly intriguing. When the AI analyzed the patterns over time, it found variations that seemed to correlate with Voyager's instrument activity. When Voyager's instruments are actively collecting data, the pattern shows subtle changes that align with measurement intervals. When the instruments are less active, the pattern stabilizes. This behavior continues across multiple data sets, suggesting a possible interaction with the spacecraft's operations. Dr. Jason Chen, a space scientist consulted on the project, noted, "It's as though the environment responds to our measurements in subtle ways." This behavior is reminiscent of how spacecraft instruments can influence their measurements, such as when magnetic fields interact with sensors. But again, this is happening in a region where such effects are not fully understood. These effects are typically subtle, not dominant patterns in data. Further analysis revealed another detail. The pattern became more pronounced as Voyager passed the heliopause, the boundary between our solar system and interstellar space. It's as if Voyager entered a region with distinct properties when it crossed this threshold. Some scientists on the project have suggested that the heliopause might mark a transition in the interstellar medium's properties. Perhaps the conditions of interstellar space allow for phenomena that are less common within our solar system. Others point to the timing as evidence of a unique environmental feature. The timing aligns with Voyager's crossing, noted Dr. Samantha Rodriguez, a space physicist working on the data analysis. It's like entering a new region of the galaxy. But what comes next deepens our curiosity. Take a moment to consider what we're discussing here. A human-made object, designed in the disco era, is now so far from Earth that radio signals traveling at the speed of light take over 22 hours to reach it. This lonely ambassador carries golden records with whale songs, Chuck Berry, and greetings in 55 languages. And now, this ancient explorer has potentially revealed new details about the interstellar medium that could refine our models of the universe. The distances involved are almost incomprehensible. If the Sun were the size of a grain of sand, Voyager 1 would now be about 4 meters away from it, and our nearest stellar neighbor, Proxima Centauri, would still be 100 meters distant. Voyager operates in a realm of space that humans have never physically explored, a realm we've only glimpsed through telescopes and mathematical models. If you've made it this far, you're clearly into the deep stuff. Hit like and let us know your thoughts in the comments. Interstellar medium, cosmic phenomena, or something else? Your insights might inspire further exploration of this mystery. Before we continue to the most thought-provoking possibilities, I want to acknowledge that what we're discussing is based on ongoing scientific analysis. NASA has stated that analysis of historical Voyager data is ongoing, with new tools providing fresh perspectives. Peer-reviewed papers are being prepared to share these findings with the scientific community, pending verification. Let's explore a more speculative interpretation of this finding, one that's being considered by scientists studying the data. What if what we're seeing is evidence of complex structures in the interstellar medium, perhaps influenced by galactic magnetic fields? According to current models, the interstellar medium may contain filamentary structures shaped by magnetic fields or cosmic rays. Interstellar space, free from the influence of our solar system, might be precisely where such structures become detectable. The pattern could represent variations in these structures, revealed through Voyager's data. Imagine how a magnetic field shapes plasma. Complex patterns emerge, preserving some of the underlying physics. Similarly, what Voyager may be detecting could be a signature of the interstellar medium structure. Dr. Michio Takahashi, a space scientist at Caltech who has reviewed the data, describes it as potentially a new window into the interstellar medium's dynamics, something researchers have been studying for decades. If so, Voyager 1 may have captured valuable data about these structures, transforming our understanding of the galaxy's magnetic environment. Dr. Sarah Matt, a physicist at Cambridge, suggests another possibility. What if the pattern reflects a transition zone in the interstellar medium? This concept, reminiscent of boundaries predicted in some astrophysical models, could explain why the pattern appeared as Voyager crossed the heliopause. These zones might separate regions with different plasma or magnetic properties. The implications would be significant. Our understanding of the interstellar medium as uniform might need refinement. The properties we've measured might vary across galactic regions, valid within our solar neighborhood, but subject to variation at greater distances. But what if the answer lies in further exploration? Here's the thought-provoking insight that NASA researchers are still analyzing. When the AI examined the full pattern across multiple years of data, it discovered something that sparks curiosity. The pattern contains complex variations, possibly related to plasma wave frequencies or magnetic field oscillations that are unlikely to be random. Statistical analysis suggests these patterns are significant, though their origin remains unclear. In the words of Dr. James Wilson, lead data scientist on the project, we're looking at something that shows signs of being structured, possibly shaped by natural processes we don't yet fully understand. Let that sink in. The AI has detected what appears to be a structured pattern in the interstellar medium, natural in origin, but worthy of further study. These patterns appear in the data's frequency or intensity, consistent across different observation periods, ruling out coincidence or data artifacts. This has led to three competing theories among the scientific team. First, the environmental transition theory suggests that what Voyager encountered is a region of the interstellar medium with distinct properties, perhaps shaped by galactic magnetic fields. The patterns could be a signature of this transition, revealing new details about cosmic plasma. This theory aligns with ongoing research into the structure of interstellar space, which remains a frontier of astrophysics. Perhaps interstellar space holds surprises we're only beginning to uncover. The second theory, termed the measurement effect, proposes that the act of Voyager's instruments operating in interstellar space influences the data, perhaps through interactions with local plasma. This leans into the territory of instrument calibration, a well-studied challenge in space science. Some suggest that Voyager's unique position might amplify subtle effects in its measurements. The third and most intriguing theory is simply called discovery. It suggests that Voyager 1 has provided data that could lead to new insights about the interstellar medium structure. The patterns could represent a natural phenomenon, perhaps related to plasma waves or magnetic fields that we're only now able to study. If true, this would represent a significant contribution to our understanding of the galaxy. So what does this all mean? If confirmed, this finding represents one of the most significant contributions from Voyager's mission. Potentially, our first detailed measurements of the interstellar medium's structure that could refine our astrophysical models. Evidence of complex plasma dynamics that would enhance our understanding of galactic environments. Or, most excitingly, new questions about the nature of interstellar space that inspire future exploration. Let's explore each possibility in greater depth. First, the plasma dynamics theory. For decades, scientists have studied the interstellar medium to understand its role in galactic evolution. These measurements are complex, requiring sensitive instruments and advanced analysis. If what Voyager 1 has detected is indeed detailed plasma data, patterns visible through AI analysis, we may have gained a new perspective on these dynamics. Dr. Miranda Chen from Caltech explains, observing plasma structures in interstellar space would be like finding a new piece of the galactic puzzle. It could validate models that have remained theoretical until now. The technological implications would be significant. Understanding plasma dynamics could lead to advances in space weather forecasting, protecting satellites and astronauts from cosmic radiation. Space travel could benefit through a deeper understanding of the interstellar medium, improving mission planning for future probes. The second possibility, evidence of complex structures, carries important implications. Models of the interstellar medium have been criticized for lacking detailed observational data. If Voyager has detected patterns shaped by magnetic fields or cosmic rays, it would provide concrete data for refining these models. Professor Robert Jansen of Princeton University noted, confirming the existence of complex structures would enhance how we understand the galaxy. It would mean that what we perceive as uniform plasma is actually shaped by intricate processes. This could lead to breakthroughs in understanding star formation and galactic evolution, key questions in astrophysics. The third possibility ventures into exciting territory. If the patterns detected in the data truly reflect a new phenomenon, we may be uncovering a new aspect of interstellar space, albeit a natural one. Dr. Eliza Sharma, an astrophysicist and researcher, puts it in perspective. Throughout history, every time we explored new frontiers, we've been surprised. We thought our solar system was typical. We were wrong. We thought our galaxy was ordinary. Wrong again. What if our assumptions about interstellar space are equally incomplete? For now, NASA has assembled a team of physicists, mathematicians, and astrophysicists to study the data. This team, working within NASA's research framework, operates across multiple institutions and includes experts from fields like plasma physics and data science. They've also begun analyzing Voyager 2's data, currently following a different trajectory through interstellar space, to look for similar patterns. Voyager 2's trajectory provides a crucial comparison, helping determine if we're observing a real phenomenon or an instrument effect. The AI continues analyzing the data stream, slow as it is, searching for patterns that might reveal more about this scientific puzzle. Every day, as Voyager 1 travels another million miles into the unknown, we learn a little more about our galaxy. If this finding changed how you see the universe, you won't want to miss what's next. Subscribe and turn on notifications so you don't miss our upcoming exploration of what Voyager 2's data might reveal and the ongoing research NASA is conducting. We'll also be exploring the fascinating connections between the patterns in Voyager's data and theoretical models of the interstellar medium developed by scientists over decades. These connections raise exciting questions about our galaxy's structure. The universe is full of wonders, and together we're uncovering them. Until next time, keep looking up and out